Find all functions f that satisfy the differential equation y prime equals e to the negative 4x minus 1 over 1 plus 9x squared plus sine of x over 2. There are three terms in this differential equation. For the first term, we can guess that the antiderivative of exponential is still exponential. For the last term, we would guess that the antiderivative sign is negative cosine. Remember that we can never change the inner function, so we would have to rewrite the inner function. We can only guess the outer function. For the first term, the outer function is e to the power, and for the last term, the outer function is sine. For the second term, this is not a polynomial, but we recognize that this is of the form 1 over 1 plus a quantity squared, and that quantity is 3x. The quantity 3x squared is 9x squared. Since this is of the form 1 over 1 plus u squared, we will guess that its antiderivative is tangent inverse or arctangent of u. In this case, u is 3x, and again, we can never change the inner function. So our initial guess will have to be y equals e to the negative 4x minus arctangent of 3x plus cosine of x over 2. And this is not correct, but this is the general guess for now. We then check this guess. Y prime equals the derivative of e to the negative 4x is e to the negative 4x times negative 4, and we don't have that factor negative 4, so we would need to update our guess, minus the derivative of tangent inverse of 3x is 1 over 1 plus 3x squared times the derivative of 3x, which is 3, and we don't have that factor 3, plus the derivative of cosine is negative sine x over 2 times the derivative inside, which is the derivative of x over 2 or 1 over 2. And again, we don't have that factor 1/2, and we also do not have the negative sign, so we would need to update this. To update this, we simply multiply the reciprocal of the extra factor. We don't have the factor negative 4, so we would multiply negative 1 over 4. The negative 1 over 4 times the negative 4 will cancel out. We don't have the factor 3, so we would multiply 1/3, and we don't have the factor negative 1/2, so we would multiply it with a factor of negative 2, the reciprocal. And then we check this again. The derivative of negative 1 over 4 e to the negative 4x is, first we bring down the negative 1 over 4, and the derivative of e to the negative 4x is negative 4 times e to the negative 4x. The negative 1/4 that we place in the front of our guess there will cancel out the negative 4, giving us back e to the negative 4x, and that is what we want. Minus, if we bring down the factor 1/3, we see that the 1/3 canceled out the 3, so we have 1 over 1 plus 3x squared is 9x squared. Minus, if we bring down the factor negative 2, we will see that the negative 2 times negative sign will be a positive 2. The positive 2 times the 1/2 will cancel out, so we end up with a plus sine of x over 2. So this checks out. In the final answer, we would need to add a constant c. So the antiderivative, or all of the functions that satisfy the differential equation, is y equals negative 1 over 4 e to the negative 4x minus 1 over 3 tangent inverse of 3x minus 2 cosine of x over 2 plus c. This plus c will give us infinitely many function f, and y is the function f of x that we're looking for. And again, this constant c will give us all functions that satisfy this differential equation.